Hi there. Today I'm going to demonstrate how you can leverage IntelliMagic Vision to identify imbalances in your HPE 3PAR environment. In this case, we will look at how the workload is distributed across the front-end resources. Not all imbalances are bad, but obviously there are some that are potentially disastrous. If this truck in the picture keeps moving forward without a serious correction, the truck will tip over. A lot of systems are inadvertently put in production with imbalances. While imbalance will probably not tip a system over, it is important to know if they exist as they can limit system throughput. In this demo, I'll show you how you can easily identify and correct front-end imbalances within an HPE 3PAR storage system. I'm going to show how well balanced an HPE 3PAR's front-end ports are. The balance chart shows the average rate indicated by the green dot, the 10th and 90th percentile indicated by the green rectangle, and the minimum and maximum value indicated by the yellow rectangle. This chart has one bar for each system representing the fiber throughput megabytes per second. In this case, you can see that the bar on the left is bigger. This indicates that the system, monotice_2849_0, has a greater amount of variance. Let's drill down on monotice_2849_0 and see how the workload is distributed across the ports. In this chart, you can see the port number along the x-axis and the fiber throughput in megabytes per second along the y-axis. The top 4 ports have a significantly higher workload than the rest of the ports, with an average around 58 megabytes per second and peaks up to 189 megabytes per second. Let's look at the port speed of one of the busy ports. The port speed is rated at 8 gigabytes. The current peak throughput of 185 megabytes per second converted to gigabytes per second is approximately 1.85 gigabytes, so the port is currently operating at about 25% its bandwidth. Depending on the mix of read and writes, the transfer sizes, and the efficiency of the processors, the port may not be able to reach close to its maximum bandwidth. Typically, ports are able to achieve about 75 to 80% of their rated throughput capacity before a bottleneck is hit. In this case, we are not overly concerned with the imbalance because even with the peak throughputs, there's plenty of headroom. In any case, it is good to understand the process for rebalancing the workload across the existing ports. Let's take a look at what we might do in order to rebalance the workload on these busier ports. We will drill down from one of the ports to the associated volumes to understand the associated hosts. This chart shows the volume throughput for the top 30 volumes associated with the busy ports. In this case, there are peaks at 12 p.m., 9 p.m., and 10 p.m. Let's look at which host is driving the load. The host system is named QOXAA390. Let's take a look at how much work is being driven by that host. You see that almost all of the workload on these ports is associated with this host. The only way to reduce the amount of throughput to these ports is to spread the host across additional ports, but this would require additional host ports as well, so it's not an easy fix. These ports should be continued to be monitored to ensure they are not reaching their throughput limits so that response times are not impacted. IntelliMagic Vision was used to identify an imbalance in the front-end ports of the HPE 3PAR system. IntelliMagic Vision uses expert knowledge about systems, configuration, and workload to proactively identify potential risks in the environment. The user interface integrates the logical and physical components to allow for easy drill downs and identification of root cause. If you would like to find out more about IntelliMagic Vision for your environment, please shoot an email to info@intellimagic.com.